Everyone. So a lot of people are asking me how sugars can cyclize, and how mutarotation works, and how to tell, like, just from looking at the cyclized structure, if something was a D or L sugar, or if it's alpha and beta and that sort of thing. And so I'm going to walk you through the way that I understood it, and it's like the actual mechanism of how that cyclization works. It's an intramolecular hemiacetal reaction, if you remember that from organic chemistry. And so I'm going to show it to you with D-glucose just because that's what you'll be working with, the majority of the time during the semester, and especially, when you start glycolysis and stuff, it's extremely helpful just to know what glucose looks like off the top of your head. But this method will work with pretty much every sugar. You can apply this to any sugar you want to. So here's D-glucose, and obviously we can tell it's D right now because this OH is on the right-hand side. And so if I want to cyclize this, if I want to turn this into the ring form, I just blanked on the actual name for that. But what I'm gonna start doing is turning it on its side like this, so that what I have, and this is a little bit weird to visualize initially, but what I want to have is like this line is like a string of carbons, and so I'll have my aldehyde over here, my CH2OH is over here, and so when I do that, what I'm gonna do is I'm gonna draw it as if it was already halfway forming a ring, and you'll see why in a second. So if I were to draw it like that, okay, so this is a hydrogen. We're not counting that as a carbon. That's the aldehyde hydrogen. This is carbon 1, 2, 3, 4, 5, and 6 in that order right there. And so because of the way that I turned it, because I turned it this way, that's why the OHs on the right will be going down and the OHs on the left will be going up. So for glucose, that means I've got down, up, down, down, and then the rest of these are just hydrogens. And then this is my CH2OH right there. So you can kind of already see, it's getting to be the ring, but what happens is, that this OH has to attack that carbon for this reaction to actually happen. And the way that it's drawn right now, this OH is not in a great position to do that. And so what ends up happening is this bond actually rotates. It rotates this way to get the OH into a better position to do it. So you essentially want the OH to come up to where this CH2OH was. And that can be a little bit hard to visualize at first. So essentially what that looks like is it'll be like the same bond pattern, but essentially my CH2OH will be up here because I rotated it. The hydrogen goes down here and the OH comes off to the side. Now, this OH has two options, and you learned this in organic chemistry where, if you have that sp3 hybridized thing, like this aldehyde, and you have these regions of electron density, or electron paucity, I guess, like above and below that plane that the bond is in, you can attack either above or below that bond. And so attacking above or below is what makes it, alpha or beta. And so essentially this is kind of random, and this is why, mutarotation will switch between those two forms all the time. But when this OH attacks that carbonyl, what's going to happen is, depending on whether that attacked from above or below, you're going to form this bond, it looks really bad. Don't worry about it. But you know what I'm getting at. You get that bond, and depending on which direction it attacked, your OH will either be below here, or it could be on top over here. And for glucose, or any other 5-membered ring like this, the general mnemonic that he uses is like a batter up beta. So if the OH is above this plane, I guess, like on top of the hydrogen, this is beta D glucose. And you can tell that it's D because this CH2OH is on the top. Because I'll show you what it would look like if it was L. If it was L, let me bring this glucose down here. If it was L, and my OH was over here, then what would end up happening when I draw that like intermediate form that I had drawn earlier, so this all stays the same. So OH is over here, here, here. But over here, what ends up happening is my CH2OH stays there. Because this OH is on the left, it's actually going to be on the top here. And so when I do this, instead of rotating this way like we did with D-glucose, we'll actually have to rotate this way to get this OH where that CH2OH is. And so what that looks like, my CH2OH will be down here, my OH will be there, my hydrogen's there. When my bond forms, it'll look like that. And you can see that the CH2OH is down instead of, up here. So this would be beta D glucose. This one would be beta L glucose. And so I hope that was helpful in sort of understanding why these reactions happen, and how to tell very quickly if something is D or L from looking at the ring form. And yeah, I think that's pretty much it. I hope that was helpful.